Hello, fourth grade, and welcome to lesson 8-1. Your lesson today is going to be on equivalent fractions using area models. So let's go ahead and watch our short video, and then we'll jump into our notes and guided practice together.
What are some ways to name the same part of a whole? Think about this question during the lesson. James ate part of the pizza shown in the picture. He said 5/6 of the pizza is left. Cardell said 10/12 of the pizza is left. Who is correct? How can you tell from the picture that 5/6 of the pizza is left?
So let's stop and look at our picture. Now we know that there were originally spaces for 6 pieces of pizza here. Now one of them is missing, so the only thing we have left is 5 pieces left out of the 6 pieces. So your top number tells you how many pieces you've got. The bottom number tells you how many pieces there were in total. So your top number, called your numerator, is how much you have. Your bottom number, your denominator, is how many pieces are in the whole. So we can tell that there are 5/6 of the pizza left because there are 5 out of the 6 pieces still on the tray.
In a fraction, the numerator is the number on top. The denominator is the number on the bottom. The denominator tells you how many equal parts there are. What does the numerator tell you? The numerator tells you how many of the equal parts are being talked about. The pizza was sliced into 6 equal parts, and 5 parts are still in the pan. One way to see who is correct is to use an area model. Draw a rectangle and divide it into sixths. Shade 5/6. Why is this area model labeled 5/6? The model has 6 equal parts, and 5 parts are shaded. Then divide the rectangle into twelfths. How many parts are shaded now?
Select your answer.
So what they've done here is they took the exact same shape and they just cut those pieces in half. So now we have twice as many pieces. The same amount of the total shape is still shaded in, it's still colored in. But since now it's cut into smaller pieces, each whole piece was cut, or each one of the shaded pieces was cut into 2 smaller pieces. Now we can see that there are 2, 4, 6, 8, 10 out of the 12 parts that are shaded in.
Ten parts are shaded now. Why is the second area model labeled 10/12? The model has 12 equal parts, and 10 parts are shaded. The number and size of parts differ, but the shaded part of each rectangle is the same. 5/6 and 10/12 represent the same part of the model. They are equivalent fractions. Equivalent fractions name the same part of the same whole. Another way to see that the fractions are equivalent is to use a different area model. Draw a circle and divide it into sixths. Shade 5/6. How many parts does the circle need in order to show 10/12?
Select your answer.
So if we want to show it in twelfths and we want to have 10/12, we have to have 12 pieces to work with because 12 needs to be the number of parts that we have, or 12 needs to be the total number of parts that we've got. So in order for us to show 10/12, we need to have 12 parts.
The circle needs 12 parts. Divide the circle into twelfths. Now 10 parts are shaded, so the circle shows 10/12. The number and size of parts differ, but the shaded part of each circle is the same. 5/6 and 10/12 are equivalent fractions. Both James and Cardell are correct because 5/6 equals 10/12. Does it matter what shape is used to show each of the two fractions? No, either shape could be used as long as the same shape is used for both fractions to justify that the two fractions are equivalent. 5/6 of the rectangular model does not have the same area as 10/12 of the circular model. Now you know some ways to name the same parts of a whole.
I hope you liked working with these fractions.
All right, let's go ahead and take a look at our notes and our guided practice for this lesson. So for our notes, what are some ways to name the parts of a whole? Well, first, let's define what fractions are. Now, fractions are parts of a whole, and they're made up of two parts. We have our numerator, which is the top number, and we have our denominator, which is the bottom number. The numerator tells you how many parts you have out of the whole. The denominator tells you the total number of parts in the whole. So 2/3 or 2/3 tells me that I have 2 out of the 3 parts. So if I drew my shape over here, I shaded 2 out of the 3 parts to show 2/3. Now, as far as equivalent fractions go, equivalent fractions are fractions that show the same part of the whole that's being shaded, just using different numbers. So 2/3, if I took the same shape and I drew it over here, but I cut it across the middle, now I have twice as many pieces. So each one of these pieces was cut into 2 parts. So 2/3 over here, the same amount is shaded out of the 1, 2, 3, 4, 5, 6 pieces now. I have 4 out of the 6 pieces that are shaded. So the same amount of the shape has been colored in. We just cut them into smaller pieces. Now, I want you to notice the relationship here. What is the relationship between the numbers? Look at the numerator. How did we get from 2 to 4? Look at the denominator. How did we move from 3 to 6? Now, when we cut the shape in half like that, when we cut the pieces into each one of them being 2 pieces instead of 1, we basically doubled it. So I doubled the number of pieces that I had colored in, and I doubled the number of pieces in the whole. So what I did was I multiplied it by 2. So 2 times 2 gave me 4, and 3 times 2 gave me 6. So since we cut the rectangle into twice as many parts, even though the same amount is shaded, the numbers changed a little bit, but they changed equally. Both of them were multiplied by 2. Let's take a look at another example. How is 2/5 an equivalent fraction to 6/15? So if I had cut my shape into 6 parts, or sorry, into 5 parts. So I had 1, 2, 3, 4, 5 parts, 5 tall rectangles in this rectangle. And I shaded in 2 out of the 5 parts. Now, if I wanted to make it into 15 parts, how do I go from 5 to 15? Well, I had to multiply it by 3. So I had to cut my shape into 3 more parts. So I made 2 more cuts here. So now I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 parts. So when I divided the rectangle into 15 parts, the parts that were shaded now became 6 pieces instead of 2 pieces. So how did we get there? How do we get from 2 to 6? In order to get from 2 to 6, I had to multiply it by 3. And from 5 to 15, I also had to multiply it by 3. So whatever is happening to your numerator also needs to happen to your denominator for it to be an equivalent fraction. So since I tripled the number of pieces that I had in the shape, that also tripled the number of pieces that were shaded. There were smaller size pieces now, but it was still the same amount of the shape. Let's take a look at your guided practice. Why is 3/4 equal to 9/12? When the rectangle is divided into 4 parts, 3 of those parts were shaded. But if we divided it into 12 parts, we're also dividing the shaded parts into more smaller pieces that make 9. So in order to get from 3 to 9, we multiplied by 3. To get from 4 to 12, we also multiplied by 3. For number 2, 2/4 was equal to what number over 8? So I had to look, how did I get from 4 to 8? Well, I had to double my number. I had to multiply it by 2. So if I did that to my denominator, I also have to do that to my numerator. So 2 times 2 gave me 4. So the equivalent for 2/4 is 4/8. Now, your number, your fraction can have a lot of equivalent fractions. It's not always going to be just one. But right now they're asking you for just one. And for number 3, 1/3 is equal to 2 over something. So how did we get from 1 to 2? Well, we multiplied it by 2. So if I multiplied the top by 2, I also need to multiply the bottom by 2. So 3 times 2 gave me 6. So 1/3 is equal to 2/6. Those are equivalent fractions. That's it for today's lesson. If you guys have any questions, please let me know. Otherwise, I hope you have a great day. Take care. Bye-bye.